In this video, we're going to use properties of parallel lines and transversals to determine the length of segments. When we have parallel lines crossed by a transversal, we create segments between those parallel lines. If we have 3 or more parallel lines cut by more than one transversal, we actually create proportional pieces. So we have an example here of pieces that we could set up in ratios. So segment PQ is proportional to QR, which would be equal to the ratio of DE over EF. Or we could look at not just on the same transversal, but going across the set of lines. PQ is proportional to DE, the same way that QR is proportional to EF. So we would use those relationships to set up a proportion and solve a problem. Like in this example, we're given 2 transversals that cross 3 parallel lines. So I have 5 and 7 that correspond on that same transversal, and X and 9. Or I could also set it up across the transversals and say 5 over X and 7 over 9. Now that I have my proportion set up, it's just cross multiply and solve. So 7x equals 45, and so x is 45/7. In this example, we have more than just 3 parallel lines crossed by 2 transversals, so we have more proportional pieces that we can compare. So I'm going to use the 2 and 3, the parts that I have both numbers in, to help me solve for x and y. So I have to match up my pieces. I know 2 matches with 3. 3 plus x is going to correspond to 24, and y corresponds to 3y minus 8. So I can use those pieces to set up the proportion y over 2 equal to 3y minus 8 over 3. And then I can solve that resulting proportion. I could also set up another proportion to solve for x using 3 plus x and 24 going across the transversals, and 2 to 3. Notice that 3 plus x and 2 are on the same transversal, so that's why they are both in the numerator of their ratios. I'm going to leave it to you guys to solve each proportion for x and y. Go ahead and set up the proportions and solve for x and y in example 4. We have another theorem that we're going to be looking at for parallel lines and transversals. If we have a set of lines and transversals where our lines are parallel and those transversals cut through those lines and create congruent pieces. If they do that for one transversal, this theorem says that if it cuts congruent segments on one, it's going to cut congruent segments on every transversal that crosses it. So I could draw another transversal, and those pieces that are between those parallel lines will still be congruent. So being able to solve for x here, if I want to find the value of x, I would have x plus 1 and 2x minus 5 that are going to be congruent pieces that are cut by that transversal. So I would set their measures equal to one another and then solve for x. And so I see that x is 6. If I were to plug 6 back in to find the measures of those pieces, I notice that I get 7 for each measure, which verifies that those pieces are congruent. You guys are going to be responsible for doing example 6, and we'll answer any questions that you have in class.